Okay, in this video I'm going to show you how to set up and simulate a CMOS circuit using the ALD 1106 and 1107 device models that we have for the class this semester. So first we're going to start by making a new schematic, and we're going to instance a couple of, I'm going to use 3-terminal pmos transistors in this particular case. Maybe I'll also show you a little bit later how to do this with the 4-terminal MOSFET symbols. But these 3-terminal MOSFET symbols, you'll notice that they're denoted here by U instead of by M, and that's because in order to have the sort of default bulk connection in LTspice, we had to make these transistors basically subcircuits that contain a single transistor with the bulk terminal connected to a global node called VDD. And in order to actually get this work, we're going to need to have a VDD symbol, which is this thing, which, if you like, is kind of like a connection to the power supply rail. And that symbol will make sure that the global VDD node is defined adequately for use with the 3-terminal MOSFET symbols. I'm also going to use a ground symbol here. You could use the default ground symbol that LTspice has built into it if you'd like. I'm going to wire the circuit up. And have my output. And I will label bias. The input. And the output. And I'm going to put in some voltage sources over on the side. One for the power supply, one for the bias, and one for the input. Copy my ground symbol here. Copy my VDD symbol. Make this one VDD. Let's set that to 5. I'll make this one the in. Or actually, I'll make this one VB. I'll make this one V in. And I'm going to set VB to maybe, well, I don't know, 4.3 volts. Kind of a round threshold. And we'll set this one to 1. Copy the labels here to hook these up to where they need to be. Draw some little wire segments here. Okay, we're almost ready to simulate. A couple things we need to do. First of all, we need to put in this spice directive .include ENGR 2420.sub. And we will save this in a place where that file actually lives. And let's see. Here's my subdirectory, and I'll call this p source folder. Yes, I do wish to replace it. And now we should be in a position to simulate. So actually, I'm going to change the absolute current tolerance to a picoamp, just because I think we're going to be kind of in the nanoamp territory here with this bias level, and so a nanoamp is probably not quite enough resolution given my bias level. So now I'm going to click the little running guy. I'm going to do a DC parametric sweep. I'm going to sweep the input from 0 to 5, and let's do 10 millivolt increments. And I'm going to tile my Windows vertically, and then I can click on the output and you can see the voltage transfer characteristic here. So this is the identity line, V out equals V in, and you can see that the output, which is the source of U2, is slightly above the identity line, and it hits the power supply up here at extrapolated about 4.3, which is what you would expect. Okay, so that's the 3-terminal version. Now if we wanted to do this with the 4-terminal MOSFETs, where we don't need this VDD symbol here, let's make ourselves a new schematic, and we will get some 4-terminal MOSFETs, like so. And with these, what you do is you right-click on it, you change the model name to ALD1107. And I'm going to, instead of using my VDD symbol, I can put in here VDD, like so. And I have to connect up the bulk terminal. Actually, I don't like that very much. That's better. I'm going to connect this bulk terminal up there as well. And put a ground symbol down here. Label the output. And we can label again VB and VN. I'm going to put down some more voltage sources over to the side. I tend to like to cluster my voltage sources over on the side rather than just having them randomly in the middle of my schematic. And we can wire the grounds, and we can copy these labels. VB, EN, and VDD. Okay, now I need my little ENGR 2420 include statement. And let's make sure that okay, we're still at a picoamp because we didn't restart the program. We'll save this as P source fall 4. Now we can run this DC sweep. And let's close this one for the time being. Tile vertically, zoom in here. And you can see it's the same thing. And again, there's the identity line, there's the source follower transfer curve, and that is all for the time being. Thank you very much.